Awesome. So I'll just get things started. So before I even get started, so I just want to give a quick overview of so what we do and what are the things we work on as well. Pretty much like I know the title says like we are going to talk about shaders and all the tech stuffs which we work on the game. But on the other side, what we want to do is like we want to share our experiences, like so what are the things which we faced and how we tried different options to get things resolved. And I'm just going to walk through our journey. So that's going to be it. And before diving deep into the tech side of things, a quick introduction about me. So I'm Abraham, and I'm the studio head and creative director of Ayelet Studio. And pretty much, I spent my most part of my career as an enterprise architect. So I was working on AI, LLMs, on all the cloud side of things. And I'm a huge gamer as well, so I'm really passionate about the narrative-driven games. And that's where it all started. Like we started working on a game called Unsung Empires, the Cholas. And this is the second part. Just to give a bit of overview about the game, it's an action-adventure one. It's entirely narrative-driven. And one of the biggest challenge which we took as a team is building the 11th century Tanjore. So in our game, like we are trying to recreate the entire the city of Tanjore, which is entirely set in 11th century. So there are, and the other thing over it is we are going to release it in PC, PS5, and Xbox Series S and X as well. And that adds like another set of overhead where we need to do like the optimization side of things, like say how we are going to make it run at 4K 60. That's what we have set as a benchmark. And before I go and talk about all the rants of what are the things which we faced and how we fixed it, I'll just show a quick a world show reel. Like, I just want to give an overview of what we are trying to build it as well. So let me play this.
போட்டி போட்டு வென்று வந்த மீடியா உன்னோட போட்டி போட வண்டி யாரு
the world which I was talking about and which we are trying to build as well. So, and as you can see, like we have like lot of different architectures. So even the temple which you saw on the video, it's actually a real world one, which is still there and people visit there. And the challenge here is like now people know what exactly it looks like. So, and we even we are just creating a 4-kilometer cross 4-kilometer map. That's exactly the 1:1 scale of the Tanjore. And some of the other things is like, I know definitely the FPS is going to be the ultimate, the final number which makes sure like we run the game properly. But we want to make sure like we wanted to present a most authentic experience for the player as well. So the song which you heard is from our game, which is composed specific for this. And definitely I'm not supposed to release the song now or some of the visuals which are supposed to be released after like the Xbox even. But the thing which I'm supposed to, which is I'm conveying is like we want to give an immersive experience for the player, and all the set pieces in the game is going to be crucial for the player immersion. And one of the huge contribution to the immersion is definitely audio is one side, but the environment, the world. And we definitely know like Unreal Engine is one of the best for creating that immersion. And that's where like we went with Unreal and we started building all our world using like world partition. Pretty much like from the 5, world partition is one of the best thing that happened to us. Because one of the huge challenge working with the team is like we actually work on the same map with all the different actors. And if people, there'll be conflicts, people loses their changes and all the other stuffs, but we're able to do it efficiently with world partition. And even on doing all of these, there are like a few challenges we face. One constant thing which I try to discuss with my team is like, we want performance, but we want visual richness as well. So how we are going to balance that? And this is, I think, this is one of the main questions that happens in every single game studio, right? So we want the quality, but we want performance as well, but what is going to be the trade-off? So that's where we figured, like, we sat together and we found out that there are a lot of challenges which we face. And we just try to segregate our problems and we try to fix like each one of it. And one such thing was the shaders. That's where the whole the presentation came up of what we did that worked for us, and that might work for you all too. And I want to walk through the architecture and how we implemented it. And some of the key challenges is the material system complexity, right? Like the world which we are trying to build, there are a lot of small props that keeps on adding. You never know, like even it might be like even their screen percentage is like less than 5% or 2%, but that consumes a substantial amount of memory. That causes bottlenecks. And one of the best things which I say is, it might be small, the triangle count might be small, even it adds like 4 or 5 draw calls. But when you add like thousands of those assets into the world, that definitely hits the performance part. We won't even realize, and when we were at a particular point, and when we look back, we need to optimize a lot of different props and trying to come back and reiterate it, and that we lose a lot of times on that too. And that's where we did, and when we figured out a particular point where we found out that we are not getting like a really good performance, so what are the key problems that we are facing? And that's where like pretty much our entire team, we sat and we found out that even like building at 15% of the world, we got more than 450 plus unique materials that were loaded. And there are like, even if we parameterize it, the instances, we have like a bottleneck of like, it has to be like 127. And definitely on the texture memory, one of the key things is like our minimum spec for our game is 1650. I know it's a pretty old one, but there are a lot of people who uses it. And that makes the texture memory coming to like, say, we have a budget of about like 2 gig. And now we need to build a world that should be like really good, but we need to optimize it really hard that makes sure that it runs really well on the low-end PCs as well. And this is one set of things, pretty straightforward, I would say. But that's where the draw calls comes in. So say for every props or for every asset, you have like a lot of different materials that get loaded. Even on the CPU side of things, on the mechanics side of things, we have a lot of ways to identify like which is taking what. and we even pinpoint it with insights, Unreal Insights, and we can say like these are the process that takes or consumes more memory. But on the material side of things, we don't have a lot of metrics to identify that. And that's where we figured out that we need to have like some set of checkpoint at particular point of the map. And even we added those things as a part of our quality assurance process as well. And the next one is, I know like whenever we say about building worlds, people just say like, nah, it works better. So it might be a really off thing, but I restrict team to use Nanite for all the small things. Like there are like set pieces that are present in the game, which is really complex, like something like the temple. You have like a lot of small details that needs to be there. There are like, it's a huge asset. For those, Nanite works really better. But one thing you have to consider is what is going to be your CPU overhead. What are the impact on CPU? I think that is going to be the key thing. Just turning on Nanite won't fix anything. And definitely using the in-engines layer system, there is always like a balance as well. You need to check the material complexity as well. What is their impact on performance again? So that is another thing. And the next option is like, can we do like a parameter collection for the material, create instance for it, and how to do that? So that's where like we kind of picked the material layer part alone, and we figured out why don't we like tweak a bit, set a process, and build the system around that, and that's what we created this. And even on the FES budget-wise, these are the three main things which we factor it. It might change based upon the game as well. So on the GPU side, we prioritize these things as like the top-down, and similarly for the CPU. And for the other thing, the audio comes at the last for us, but definitely like we use like Wise for integrating with all the different platforms. And when we say like even the small things, even the audio file causes impact, which we learned it in a hard way when we released the first part. So just make sure like you factor all these things even when importing it. Something like one such incident that happened last week is when you're importing an animation in Unreal, there will be a default option that we won't check it, that causes creating lot of frames in the animation. So these kind of things, it might be a small thing for anyone, but turning it on, it really impacts the performance of the game. And one thing which I would call is like for us, it's the reason why we figured out whatever we are building is not really performant is, it's definitely our inefficiency, I would say, like at that particular point. But then like we kind of created a baseline for how many number of draw calls we need to have, what should be the texture memory, and what's our target frame rate. That's where we kind of did all the different specifications, and we said like, okay, like now shaders can use like this much X amount of memory, and what are the things we can do to optimize it as well. And some of the key challenges, definitely there is a visual trade-off when we are using just the material to handle all of your asset quality. And that's where we even like figured out like what are the things which we can tweak it, make sure like it looks really good, and what are things we can just say like if you're going to just fill the world with like few props, like something like a stone, or it's going to be like a house, or it's going to be more of a like a filler. So we can definitely go with the layering system, and we can have like a bit of trade-off as well. And that's where we kind of named it as DICE, but it's actually a strategy which we use it to, which we integrated it as a part of our asset creation pipeline. And technically, it's nothing but it's a material organization strategy which we use. And we primarily use Maya for all our asset development, and we integrate within Unreal. And just to give a simple example is some of the feature is the layering. Definitely, when we say like multiple layers you can combine on a single asset, this opens up a huge thing for us. Something like, say, you're creating a house, and I just want to iterate it whether like there are 3 different types of stones. I just want to do like a R&D, say like I'll just switch to the first stone, and I'll say like, it looks good. And if I want to try it out the second thing, normally it goes to the 3D artist. Now we need to like figure out the entire flow. Like we need to give some samples or tweak it, and it comes into the engine, and we just preview it. So what we're able to do is, like, say, by using the layering system, we created a general shader asset repository where you have like a common material shaders for all the most used ones, I would say. Say like a wood or like a metal. Even in metal, there is a steel or aluminum. So even on that front, you have like an additional layer to add like the dust particle on it, or if you want some, say like a turned out one, or if you want even on the third layer, if you want to add mask it, change the material to gold or something, you can do that. And some of the thing that really worked out is we're able to iterate it quickly inside engine and try it out like different things. And one of the huge problem which we face whenever we are building the world of this scale is the variety, right? Like no gamers want to see the world repetitive. So we try to make it like tweak everything on the material side to bring out the variety or the variations. And definitely, this had a performance impact for us on the texture memory because we were able to create a common shader and we were able to reuse it across. And the third one I would say is the reusability as well. So we were able to reuse the materials, we were able to reuse the textures, and the best part is like our entire shader repository became very minimal, and we were able to kind of like think of like our initial texture memory before reiterating with all these things were around like 6 to 8 gig. Now it comes below to 1 GB, 1 gig. So which is a huge thing for us. And now at every point in time, we were able to like test it out and what are the impacts on creating this. And the architecture-wise, it's pretty straightforward. So we have the repository where we have all the common shaders, which has our own master materials. And then we create static mesh assets with that. And the mesh comes from Maya, and we texture it in, or we apply the materials in Unreal. And finally, on instances, we use layers, and we're able to add like the different variations that game demands or the art demands, and we're able to integrate it. And some of the numbers which I want to portray is, now we're able to create like multiple assets, right? So now it opens up like, say, if I was able to do like a golden handle, now I'm able to do the silver handle as well. We're able to create like bunch of assets from that, and the texture count reduced, and the draw calls reduced, and finally we are able to get like really good performance as well. Even this, I would say like the 30%, even it might be minimal, like it's even like, so we got around like maybe 15 or 20 FPS as a boost, but this, which is a huge for us. Now we can spend that particular increase in FPS for other budgets. We can say like, now we want to use like, do like Atmos rendering for the audio, and now we want to use like those kind of things that comes in, that adds value to the game too. And on the implementation wise, it's pretty straightforward. So we use master material for all the bases. So there are 3 different categories which we created. One is going to be the landscape. The second one is the props. The third one is the architecture. We call it architecture because since we are creating a more of the Indian city, like it has a lot of architectural places like the palace. You have like the temples and those things. But I would call like a set pieces that comes in for a particular chapter of the game, particular narrative, and it goes off. And even on the architecture side, we have like the exterior and interior comes in as well, because when you visit a temple, like you see like there is a lot of exterior that happens, but on the interior you have like another set of the visual which we experience. So we have those things created. And similarly, the main reason why we went, why we want a specific thing for landscape is, there are few issues which we faced is like there is a RHA limit for rendering the landscape textures. We can't just use like a lot of different landscape layers and create variations. We need to make sure we are up to that limit. So that's where like we created a separate master material just for landscape with the optimized the layering system. Because if you add more layers, you need to make sure you just check your the shader complexity as well. And this is like on the top of the master material, like we're able to do the parameter management. And on that, we're able to group all the related ones. And the next thing is like how we can reuse the common calculations. Because when it comes to shader, I would recommend like just make sure, think of it like a programming language, and try to optimize it at the root level. Because even a simple calculation like a multiply, you just need to know how many instruction count that it takes. And just make sure you follow all the stats, because shader is one thing which people kind of kind of keep it off. But I would recommend like spend some time on identifying what exactly it uses on the engine side, because engine is super efficient in handling a lot of instruction count, but we need to make sure we use it in an efficient way. And definitely the categories. The main reason why we categorize the asset in this level is we use HLODs. So HLODs is one of the best things that happen in world partition, right? So you have a loading range, and you have like you can create like a multiple different instances. So you have like a different set of configurations you can do. Like for foliages, we try to set it a different quality, because whenever we are doing a long shot or whenever the camera goes at the top, you can see a lot of different assets at the end. So we try to have like a different configurations. And for that as well, we want to have the material configuration specific to the asset categories too. And finally, the LOD strategy. Definitely, like there are multiple different the material options which we can do. So for distance object, or say for similar materials, how we are going to use the textures. And finally, we definitely want to reduce the parameter count as well. And definitely this is, so this is one thing which we, these are like the initial version of how we used or leveraged dice. The left one is the first version. The mid one is the one which we use now. The third one is the concept art. And definitely there are a lot of rooms for improvement as well. But one thing which we see is like, what are the drawbacks of using this system is, there is definitely the parameter cap. You need to make sure you can't just keep on adding parameters to tweak the layers. Just make sure you balance it right, which doesn't cause any impact on performance. Similarly on the visual as well. And you definitely need to monitor your shader compilation as well. And if you're using any dynamic parameters, just make sure you handle it properly. And finally, this way won't be suitable for all the hero assets. So hero assets in the sense like, say, the temple, or which is a huge structure that has like only one instance. You don't want to optimize visual quality for that. So you can just go in with all the nanite and with a really good material with all the different materials. Just make sure this system works really well whenever you're doing like a filler, world-filling items. So what we normally do is like whenever we are planning, we separate both the assets. Like we list down, these are the assets that's going to be the hero asset, that's going to be the important one for the game, and these are going to be the fillers. So pretty much we use it housing for our for the housing we used it, and we are using it for other assets as well. And some of the takeaway from implementing all these things is we're able to get the materials organized. Because as a game development studio, because one thing which I try to strive is like, how do we implement process that increases efficiency for the team, that helps the team. So we have our own CI system, we have our own build system, but we never had anything on the environment side that that sets a proper process. And now we can monitor like what are the common shader materials that we are using. And if you just tweak a single shader, like the master shader, now it get affected to the entire world. Normally, we just need to inspect everything and fix it when we figure out that we are not able to get the performance. Now we are able to organize it. And definitely, it increases the artist workflow as well. Or I would say like, it might be a different chain of thoughts for the 3D artist and the environment artist, but I would say like, it definitely improved our artist workflow. Now we can try variations. Now we're able to see all the different sides of assets too. And now it's maintainable as well. The best part is now we have like a different 3D asset repository where we manage all these shaders, and all the source file comes into. And one thing which we are currently working on is like integrating it into our the life cycle as well, the DevOps life cycle, so that we have like a checks there, say how many assets that have been added, because there are cases where we found out we added like, those are like the initial mistakes which we did. We added like a 4K texture for like a single grass or something. So, and now we wanted to have that set of process that runs on the DevOps pipeline as well. And now this implementation is scalable, because now we are able to adapt it to this title. Now we can take all these things to the next title, and we can keep on increasing our asset repository. So I just summarize it. So this is what we have been doing it. We won't say like this is a technical breakthrough or anything, but organizing these things, because our game is unsung MPs and shaders are more like the unsung modules of Unreal Engine. But that adds a lot of things to your work as well. So, and definitely I'm open to answering all of your questions too. And so thank you so much for attending the session. And especially I want to thank our team for doing this, because this comes with a lot of iteration and our team was able to pull it off. Especially I want to name few ones like Vijay, Praveen, Dennis, Srihari, and Javens for bringing this into life. And thank you so much.